We are ready for the last session. I am Noppol Setobol again. I have along with me Michael Larionov from the data science team. He's going to help me explain some of these agentic things that we got going on. I know you guys listen to a lot of agents and a lot of the workflows and a lot of the use cases behind it. And so we're going to spend the last session going into the tech side of it, how these agents are working underneath the hood. This is the agenda. We're going to talk a little bit about the enterprise support stack, what it means to SupportLogic, what an ambient agent is. We're just going to review the data pipeline, just to go over how we are looking at your data and bringing it into our system. And then we'll talk a little bit about those ambient agents. We're not going to go into complete detail because there's a lot of them, but we'll hit the main topic ones on the ones that are most useful for today's sessions and the ones that we didn't really cover in the other sessions from today. And then at the very end, Michael is going to talk a little bit about the Gen AI infrastructure to go over some of the generative AI capabilities that we have. So you guys have probably seen this in all of the sessions today. This is our full-fledged suite of products, the core SX and all the modules that are there. Each and every one of these modules incorporates one or multiple ambient agents that you'll see that runs behind the scenes and powers everything inside the UI. So everything that you see here is coming from one or more of those agents, either working in tandem or working separately to bring you the information that you need. Okay? And this is just an overview of everything. Earlier we talked about the data extraction layer, the signal extraction layer, and the context engine, and how important it is for all of those things to work together. Bring all those data from various sources, those various types of interactions, those various channels, bring them all together, extract those signals, and most importantly, bring the context together, right? We want to suit those up, roll them up to the case, and make it available to you. But instead of just making it available, we're going to have this orchestration of agents to provide you with the information that you're looking for when you need it, right? If you need sentiment analysis, we have sentiment agents. We talked about that earlier. If you need coaching assistance, we have that. And even in the previous session that Krithika and Hari talked about, the voice agent and voice agent and the summarization agent. All of those things are working tirelessly in the background to provide you with the information when you need it. So how does the data pipeline work? Just another high-level overview. We are connecting to your CRM system or any other system that houses all of your interactions. We're bringing it into our SupportLogic's analytical database, transferring it into what we call the universal data schema. This allows us to make our integration CRM-agnostic so that we can essentially, as Krithika mentioned, normalize the data itself. And then we feed into our ambient agents. So if you need what you need, and you know what you need, you just call upon the agents, and they'll provide it to you either in the UI, or you can provide it back into your Salesforce CRM, or you can just make it available into what we call the SupportLogic Data Cloud, which can then feed into any BI applications so that you can use it across your organization. So what are some of the ambient agents that we have available? Right off the bat is that signal extraction agent. This is using our NLP technology to extract those sentiment signals. We have a variety of them, as I mentioned earlier. We're not just focusing on the positive and the negative and the neutral. We're giving you exact reasons on why it's negative or why it's positive or why it's neutral, including the attention signals, right? What's important to them, what's critical to your customer, and what's time sensitive in terms of the information that they're providing. What we do from here is then we classify it into one of these sentiment signals, whether they fall into the right classification. And then as you use it, as you use SupportLogic as part of your workflow, you're actually providing feedback at the same time as collaborating with your teammates. Anytime you acknowledge a sentiment, you are agreeing with our sentiment agent that they detected that sentiment correctly, it is defined correctly, and you're sending that positive feedback back into the AI and ML so that it can train it, relearn it, and make it better as time goes on. As you are using SupportLogic within your organization, you are actually retraining the model constantly with using it throughout your workflow. The next thing is going to bring the scoring agents. We talked about a little bit about this in some of the other sessions where it's taking all that context from the context engine, all that information from your cases, the signals that were extracted, the SLAs that are either missed or met, your SLOs, all the other, I like to call, as I mentioned, case environment metrics are considered to produce these scores to tell you about the customer experience in real time, the criticality of their issue in real time, and the account health score once a week, according to Krithika, but naturally in real time as well. You're going to get exactly what you can focus on with the scoring agent. Then you have the recommendation agent, which will help with case routing, right? We will take a look at your historical cases and your agent's historical cases, and we will train and build an AI model based off of that to identify time overlap, skills, customer relationship, bandwidth, if there's any penalties that you've configured for your support organization. For example, you don't want this agent to be assigned 6 cases in an hour. You can create what we call a penalty or a rule set, so that agent doesn't get recommended. And once all this is being considered, we then will recommend the best agent available at that time. And I say at that time because you can call upon this recommendation agent at any time, whether it's a new case that came in, hasn't been assigned. You can use this to recommend the best agent with the right skill set to take on that new case. Or maybe you're just wanting to transfer your case over to the next available agent because your shift is ending, maybe the agent's shift is ending and you don't want to lose context. You can easily use this recommendation agent to suggest what the next available agent based off of these criteria that you see here. Then produce that recommendation score, which is that percentage on the right-hand side, which will let you know which agent out of the list of agents is best suited for the case. And now I'm going to hand over to Michael to talk a little bit about the escalation prediction agent.
In one of the previous sessions, you already saw the slides about escalation predictions, and this is the one that I'm talking about with a bunch of trees. And the algorithm was called Reagan Boosting Trees. But of course, we are not in the business of creating like algorithms, neural network architectures, and so on. The core of our intellectual properties actually lies in creating factors. We need to figure out factors that influence escalations and also sampling. This is an illustration of it's not very clear, but this is an illustration of the sampling techniques that we use. Ability to use the same case in the training data 4 times or more, because we can just shift the window. Since escalation prediction model predicts escalation happens within 72 hours, we can just shift the window, and that way we can train the model on little data as opposed to having to use really a lot of data. So the escalation prediction models are trained on the actual escalations. So since we have escalation data, we can use the actual escalations to train it. We also use the feedback that the users provide about the escalation predictions. So currently our training cadence is 30 days. So every 30 days we retrain the model based on the recent feedback and recent escalations. And escalation predictions is running every 30 minutes. So every 30 minutes you'll get a different result. It could be either the same one, so there's no escalation again, or escalation again, or if it could flip from, for example, from escalation back to non-escalation if the customer took some actions. So let me, where is the other slide? No.
Happened to the other one.
Oh, here it is. So now we shift gears and talk about AI infrastructure. Kritika already touched upon this in the previous presentation, but what it is, LLM as a service is an extension of SupportLogic ML as a service platform, which we developed 3 years ago. It allows us to have a single interface for all LLMs, so we can switch between, for example, OpenAI to Anthropic and back, or different versions of OpenAI or Anthropic models. This is also, in addition to that, it is a home to AI agents, which means that it knows the structure, it knows what the request is, it knows how to respond, it will give you exactly the same format of the response as is expected by the applications. In addition to that, it includes retrain fallback mechanism, prompt management system is very important, guardrails to ensure that the response from LLM is correct. And what is really important, it also has a systematic evaluation pipeline, which means that we can always evaluate how the new model works against the customer data, how the new prompt works, or their combination. So this helps us always to choose the best model and the best prompt. Now shifting gears to another area that we have is sex, and in particular X-Find search. As a big part of the modern AI is called RAG, which is retrieval augmented generation. What it means that you add to your prompt, you add some snippets or passages of the actual data. So that way, the response from LLM will come based on the data that you provided in your context. So this is also known as AI engineering or context engineering. In our case, what the data that we get from RAG could be case data, or it could be knowledge data. So we have multiple knowledge sources that we can access, which like knowledge bases and so on. We index them, and then when there is explicit or implicit search on the data, we search these knowledge sources, we get passages, and we add them to the context. So that after that, we get the response that is based on the data, not just a random one. And what is super important here is the yellow triangle, guardrails. This is very tricky. There's a lot of research went into how to create good guardrails. Before that, I'm going to touch upon the search technology itself. In retrieval, there is a problem when you do like a RAG. Very often, your passages are not ranked correctly. If you, for example, download some code from the internet and just customize it and use it, most likely what you get is something that is based on the vector database, which is also called semantic search. Instead, for us, in order to make ranking very precise, we're using multimodal fusion or hybrid search. This didn't come from us. This is a technology that is being used by large search engines, including Google, when they rank results. But apparently, the same technology could be also used for ranking passages for LLM processing. So let me skip to the next one. And I already mentioned guardrails. We have two types of guardrails. So one of them is we want to check if the question actually is in the domain. So if the question can be answered. This is especially important for the explicit search, but even for implicit search, you can have a case which has very little data, and we just cannot find any answer because on that data. Rather than just going directly to LLM and do a search and then get like results, like every LLM call is like 15 seconds. Instead, we have a machine learning model that we train for each customer that can determine whether the question actually can be answered. The second guardrails, or what we call relevance assessment, once you get the search results, we want to make sure that the search results have the answer to the question. It could be multiple irrelevant passages or documents that will not help at all any of the with RAG. So the second guardrails here is make sure that all of the documents and all the passages are actually relevant to the question. So in the interest of time, this last slide, we're a little bit running over, but we might have some time for questions.
Yeah.
We do indeed. Does anybody have any questions?
Hi. In terms of the relevance filtering or the the ranking of the results. Is there any ability or intent to try to quantify the age of the data that came back? How old is the information? How do you weigh what's new, current, and relevant?
We have multiple features that we use. One of them is the age of the article. Now, again, this is machine learning model. So, for example, for one customer, it might not matter at all. Other things might matter more than just an age of the article. So again, it is customer by customer because every customer has different data and they might have outdated knowledge base articles, and we definitely use that as a variable to determine the relevancy.
Hi, thanks for all the information today. And maybe the question's not relevant maybe to this presentation, but some of the things that I've heard all day today. For everything that you're doing, you're pulling data from various systems, right? And bringing it in and then doing your magic on whether it's the case management system and so on. So a couple of connected questions. Are there any limitations as to which systems you're pulling the data from? Like if it's a custom case management system, can you still do that?
We could technically do that. It's just going to have to scope out the level of work. But the way that we built our pipeline is we normalize all the data, so we are technically we are CRM agnostic.
I'm sorry?
We are technically CRM agnostic, so we could connect to any CRM.
Okay.
Yeah.
And then, of course, some of the things you're doing, like agent assignment, right? There's some prerequisites for that, meaning you need to know all the skill set of the agents need to be stored somewhere. Their schedule needs to be stored somewhere. So that's a prerequisite.
Not necessarily, no. All that stuff that you saw today is inferred through your historical cases. So when all of that is inferred through your historical cases. So we will build a model based off of your historical cases. We typically look at 2 years of your historical cases, and we can build a model based off of that by identifying.
So looking at historical case, so you can judge the capability of each agent.
Yeah.
Yep.
And like when they're typically.
If you don't have a skills matrix that you use internally, we can build one for you.
Okay.
Absolutely, yeah.
All right. Thank you.
You're welcome.
Thank you for your presentation. I have a fairly specific question. You mentioned that you train the model on the past escalations. What acts as the source of truth for what was or wasn't escalated in the past? Is that something being handed over to a higher level employee, or what kind of information is used to classify?
Yeah, I can answer that one. So as part of the onboarding process, when we're bringing your data into the system, we'll work with you to understand how you identify escalations, and we'll configure mappings based off of that. So when we bring in your historical cases, it will be based off of how you identify escalations, and we'll count the escalations the same way you would.
Specifications coming from your clients.
Exactly, yes. And every client defines escalations very differently, so we can map it that way.
Thank you again for the information. How do you measure the accuracy of the gen? I mean, like when we read it, we say, okay, this is correct or this is incorrect, but it's still the human evaluating your reply. But how do you, a part of the feedback that you can use to train the model, but in the case of the Gen AI, how do you measure it? How do you can tell me like, I don't know, 80% of your replies are accurate without asking the human? Is that possible, or how do you do it?
Are you talking about like automated replies?
Yeah, like if the Gen AI is correct or not.
I could probably. So we have actually several different metrics. Some of them are more like a classical metrics of lexical match and semantic match, but some of them are based on LLM as a judge. So we use another LLM to judge whether a given LLM gave the right response.
Is that based on what the human do after reading the Gen AI? How do you capture that interaction with the human after that person reads the answer? That's why I don't understand how you do it.
So you mean, so we have like a training, so like we have an evaluation set that we use to determine whether LLM is doing, how given LLM is doing for the given circumstances. So we use that, and this is again based on the actual interactions.
In the actual interactions of the human after giving the answer.
Oh, we're going to have to shut it down, but we'll take your question afterwards. Yeah, for sure. We'll come to you and answer those questions. But, oh.
We're good? Okay. So my question is around the timeliness of corrections. So for signals, it's okay for it to take some time to learn and get better, but for providing technical feedback or technical guidance, if we determine that what it provides is incorrect in a high volume environment, it could give the wrong information over and over again. How quickly is it going to take feedback that what you gave me was wrong, so it stops giving it to anyone else? Is that a fast turnaround, or is that the slow learning that we talked about earlier as well?
For which particular model? Because we have different cycles for different parts of the. For different models, we have different cycles.
Right. This would be for the technical recommendations.
The knowledge summary, I think.
Oh.
Yeah. Resolve-assist.
Okay.
Yeah, that.
Sure. So right now, the process right now is a bit complicated and is a little bit manual in terms of once we get feedback, we analyze it through a different LLM, validate if it's correct or not, and take those cases when there is a disagreement, and then just manually look at them. And so it's not like automatic, as opposed to, for example, signals scores in LTE, we have automatic feedback. For the GenAI solutions, it's not automatic yet. I think it's a hard problem to do automatically because it can lead to some unexpected things like a collapse of the responses. Responses will become like super tiny or will blow up, be like very large. So for stability reasons, we do this manually, but we use the automatic evaluation framework for help, because otherwise it's just too much data to review.
Okay, yeah, because that's what I was thinking about, is like, how do you keep the proliferation of bad information from continuing to cycle and cycle?
So and again, we also have guardrails which eliminate most of the cases that we should not serve to the customers should be eliminated by those. But there's never 100% accuracy, of course.
We do track the metrics of who's using which articles that are tied to the cases. So if we see someone copying like a particular article that's higher than the one that's being used, it's going to be marked as it being used as opposed to the other one not. And so we track that and how many times articles are being used opposed to the other ones, among other things like creation date and other versionings that we can consider as well. That will help provide an actual result that you like. As far as removing things immediately, you probably have to reach out to us if there's like an article that's completely non-related and you want it to be removed immediately. Just reach out to us and we can make that change for you.
Not SupportLogic, but we have others where it's like feeding us knowledge-based articles that are just flat wrong over and over again. Like, how do you get the noise out in front of the engineers?
Yeah, but if you ingest into us, you can have our agents take care of it just like that. Thank you, everyone.
Yeah, thank you.
Great job, Michael.
Yeah, thank you.